Well, hello everybody. I'll be solving an interesting physics problem on electric forces today. So it's an interesting problem, and basically what it says is that there are 2 cups of water that are sitting 1 meter apart, and we have to show that the attractive force exerted by the electrons in 1 cup of water on the protons in the second cup of water is equivalent to a massive 1 million newtons of force. And it actually gives us an exact value too. So let me just draw out the problem here. So there's 2 cups of water, and they are sitting 1 meter apart. We're told that there's 250 milliliters in each cup. We're told the attractive force, or the electric force, which is equivalent to 1.6 times 10 to the 24th power newtons. Now this is a massive number. Just to give you a quick, just give you a little comparison. The speed of light is, can you see that? I don't think that's very visible. Just write that again. Okay, the speed of light is approximately 3 times 10 to the 8 meters per second. Okay. So that's it. So this is a really big number. Anyway, so here's how we're going to solve it. We know that each molecule of water, so we know that a water molecule is H2O. So there are 2 hydrogen molecules that are bonded to one oxygen, hydrogen atom bonded to one oxygen atom, and together we have a water molecule. And we know that there are 10 protons in this molecule and 10 electrons. So I'll just write that out here. So there are 10 protons, and of course, because this is a stable molecule, there are 10 electrons. Okay, so now we know that. So we know this fact about water. Well, we know another fact. We know that the density, and this is actually given in the question, but they tell us that the density of water, at least in this situation, is 1 gram per milliliter. Okay, so this is enough information for us to determine to actually determine this number. Okay, so let's do this. Let's get the red pen out. Alright, so we're told that there's 250 milliliters of water, and we know this very important equation. We know Coulomb's law. We know that the Coulomb's constant times charge 1 times charge 2 divided by r squared gives us this guy, gives us the electric force between the 2 charges. So we know this to be 9 times 10 to the 9th power Newton meters squared divided by c squared. Alright, so now we're going to find the charge in each water molecule. Well, folks, we know that 1 Coulomb has approximately 6.2. Actually, I think I'll write it out here. Yeah, so 1 Coulomb has 6.24 times 10 to the 18th power of charge. Now we know that this amount, this is actually the collection of all the the electrostatic charge between 6.24 times 10 to the 18th power electrons. So we can, if there were this many electrons, they would have a charge of 1 Coulomb. That's what 1 coulomb really means. So and that's a really important fact. So I'm just gonna kind of emphasize that. Okay, so look, getting back to the question, well, we first have to figure out what the mass of this is, and we'll get to that in a very quick second, why we're trying to determine the mass. So we know that density is equal to mass divided by volume. Well, we're given the density, we're given the volume, so we can definitely find mass. In this case, mass turns out to be 250 grams. Why? Because, well, volume is 250 milliliters, and the density is 1 gram per milliliter. So we multiply them. So we multiply both sides of the equation by 250. 250 milliliters, we're going to end up with mass that equals to 250 grams. Now, we also know another key formula. We know that the number of moles is equal to mass divided by the molar mass. Here, I'll just write that again. It's molar mass. So, in this case, we know that our mass is 250 grams, and that's why we were trying to determine the mass of, one cup of water, and we know the molar mass of water, which, although it isn't given in the question, but we can figure it out because the molar mass of oxygen is 16 grams per mole, and water, for hydrogen, it is 1 gram per mole. Now these are, of course, approximates. So 1 gram per mole. Okay, so if you were to add the molar mass of water, it would then become 18 grams per mole. 18 grams per mole. The number of moles in 1 cup of water turns out to be, and I've done the calculations here, it is 125 divided by 9 moles. Okay, now we are going to, and another key fact that we know is that we know the Avogadro's number, which is 6.02 times 10 to the 23rd power. Okay, so now we're going to find the number of water molecules that are in 250 milliliters of water. And the way we're going to do that is we're going to take this, we're going to take the molar mass, the number of moles of water, and simply multiply it by this number, the Avogadro's number. Okay, so if we do that, if we go 125 divided by 9 moles, and we multiply it by the Avogadro's number, we're going to get 8.36 times 10 to the 24th power molecules. So we have this massive number of water molecules in 250 milliliters of water. Since we know the number of water molecules, we can concomitantly determine the number of electrons, which is going to be 10 times this number. Why? Because we know that each water molecule, has 10 protons and 10 electrons. Now that we know how many water molecules there are, we simply take this number and multiply it by 10 to get the number of electrons. So the number of electrons equals 10 times, actually I'll do this, 10 times 8.36 times 10 to the 24th power to the 24th power. Okay, so when you do that computation, you're going to get this number, and it is, let me just, okay, yeah, it is 8.36 times 10 to the 25. Yeah, so you're just raising the power of 10 up by 1. Okay, so now we know the number of electrons that are in one cup of water that holds 250 milliliters. Now, we know that 1 coulomb, so we know, as we've written here, we know that 1 coulomb is equal to that many electrons. Well, it's actually the charge of that many electrons, but we can assume that 1 coulomb has this many electrons. So, by setting up a simple ratio, 1 coulomb over x coulomb, and then we know what 1 coulomb holds in terms of charge, or is defined as that amount of charge, and we know that this is equal to 8.36 times 10 to the 25. So now we determine what x is, and x just turns out to be, actually we can get rid of that c. So x just turns out to be 133,974,335.9 coulombs. And I've done the calculations, but this is the charge that exists in one cup of water that holds 250 milliliters. Now, you have to understand that the cups do not actually exert, like, they do exert an electric force on each other, but the net force is 0. This is because the force exerted by the electrons is equally canceled out by the force exerted by the protons. And as we know, folks, that the electric force is one of the strongest forces in nature, and of course, if these forces were out of balance and out of proportion, then there'd be mayhem all over the universe. Okay, so now we're gonna do our final calculation. We're gonna take all the data that we've done computations on and inferred, and we're gonna put it into the Coulomb's law. Okay, so we're gonna go, so K is, and I'm actually gonna leave out the their unit, so that's Coulomb's constant right there, times Q1, and because Q1 and Q2 are the same amount, we can just let that be Q squared, and in this case Q is 397435.9 squared, all divided by r squared, and we know r is simply 1, so 1 meter. And so our electric force, when we do our computation, is 1.616 times 10 to the 4th power newtons. So we have proved that 2 cups of water that are 1 meters apart and each hold 250 milliliters, they exert a force on each other that is equivalent to 1.6 times 10 to the 24th newtons, or 1 million newtons of force. Now, this is massive, but it's a really good conceptual question because it ties on so many strands of physics and helps us answer a very neat question, in my opinion. So folks, I hope you enjoyed this video, and comment on how I did.